Good morning, students. In the previous class, we see some problem involving vector and modulus. Now we continue the problem in the same exercise. Next question, 8th one. Given modulus A vector value is 5. Modulus or the another name is magnitude. The magnitude of A is 5 and modulus B vector is 6 and modulus C vector is 7. These three values are given, and also this three vector satisfies one condition. The condition is the sum of A vector plus B vector plus C vector is equal to 0 vector. Then our question is find A vector dot B vector plus B vector dot C vector plus C vector dot A vector. Two data are given. Modulus of A vector, B vector, C vector, and the sum of A plus B plus C is given. Then to find this sum, first, we will take the given data. Modulus A, modulus B, modulus C is there already. We use the second data, the sum of A vector plus B vector plus C vector is equal to 0 vector. But in our finding question, there are involving dot products. So you have any idea? In the given data, there is no dot is involved. A plus B plus C is only given, and also some modulus are given. So we have some idea. Suppose squaring on both sides, A vector plus B vector plus C vector the whole square is equal to 0 vector square. I explained what is the reason to squaring on both sides. The next step is taking square on both sides. 0 vector square. If a square is involved, the vector it may be right in modulus of 0 vector square is nothing but 0. And LHS you see A vector plus B vector plus C vector the whole square. Suppose the vector symbol is not there. The number only there, A plus B plus C the whole square. You remember the formula? In your lower class we see the formula of A plus B plus C the whole square. It's not A plus B the whole square. It is A plus B plus C the whole square. I remember the formula. Suppose the vector is not there, the formula of A plus B plus C the whole square is A square plus B square plus C square plus 2AB plus 2BC plus 2C. Suppose the vector is involved, you know very well how to write. Whenever the product number, we use the dot product. So in our finding, value is also using dot. So that's why we squaring on both sides. Okay, so what is the formula of A vector plus B vector plus C vector the whole square? Same. A vector square plus B vector square plus C vector square plus 2 A vector dot B vector. In ordinary number there will be a product, but in vector using dot product. 2A dot B plus 2B vector dot C vector plus 2C vector dot A vector. So A vector square, I using the formula A vector plus B vector plus C vector the whole square. Starting term is A vector square plus B vector square plus C vector square plus 2 A vector dot B vector. 2AB. Instead of 2AB here, 2 into A vector dot B vector. We keep bracket or not. Next step, 2 B vector dot C vector plus, next step, 2 into C vector dot A vector. I already tell the RHS value become a 0 because a 0 vector squaring on both sides taking a modulus 0 is nothing but 0. So RHS value is 0. In early class we already tell we write A vector square is also modulus A vector square. Square is there. So A vector square or modulus A vector square or A square. We write any manner. But in the given data, modulus A, modulus B, modulus C is involved. So I write A vector square as modulus A vector square. So how to write B vector square? Modulus B vector square. We write C vector square as modulus C vector square. Because these three values are given in the data, so I write A vector square, B vector square, C vector square as involving modulus. You see in this three term, anyone is common? 1, 2, 3. Which one is common? In all the three terms you see the number 2 is common. So I will take outside the number 2. 2 of A dot B plus we take outside 2 B dot C plus C dot A is equal to 0. Next we using the other datas. What is the other datas? Modulus A, modulus B, modulus C. What is the value of modulus A is given? The value of modulus A is 5. Modulus B is 6 and modulus C is 7. So using this value in this table. So modulus A, the value of modulus A is 5. 5 square. Modulus B is 6. 6 square plus modulus C is 7. So 7 square plus 2 of A dot B plus B dot C plus C dot A is equal to 0. The value of 5 square, the value of 5 square is 25 plus the value of 6 square 36 plus the value of 7 square is 49 plus 2 of A dot B plus B dot C plus C dot A. You write in vector symbol, but in read we should be read it as A dot B or A vector dot B vector. So it is our required answer. We need that value only. Do you have any idea to do the next step? First to simplify the numbers. And all the numbers goes to RHS because it is our final question. Now we have these three numbers 29, 25 plus 36 plus 49. The sum of these three number values are, where we get 9 plus 6 15, 15 plus 5 is 20, so 0, remaining 2, 6, 9, 1 is 11, so 110 plus 2 of A vector dot B vector plus B vector dot C vector plus C vector dot A vector is equal to 0. So the next step, the 110 suppose goes to RHS, it become minus 110. So 2 of A vector dot B vector plus B vector dot C vector plus C vector dot A vector is equal to minus 110. The next step, we need that term only. But the term is multiplied by the number 2. The multiplication 2 suppose goes to RHS division. Or we cancel here also. I cancel in the second table. So 110 5 times. Remainder 1, 10 again 5 times. Therefore, A vector dot B vector plus B vector dot C vector plus C vector dot A vector value is minus 55. I reduce one step. The multiplication 2 becomes also division. 110 by 2 is 55, or we directly cancel here also. So it is our question to find the value of A dot B, B dot C plus C dot A. So that value is minus 55. The final answer should come in scalar. We already know what is meant by scalar and vector. So it has only magnitude. The answer is a scalar. Why? Because we add all the scalar. A dot B, B dot C and C dot E. Two vector dot product is always a scalar. So somehow some scalar value, it should be a scalar. Scalar is nothing but a constant. So the value of A vector dot B vector plus B vector dot C vector plus C vector dot A vector value is minus 55. The next question is the 10th one. If A vector, B vector are the unit vectors. Two vectors are given. A vector and B vector, both the vectors are unit vector. If the vector is unit vector, immediately we have one idea. Any unit vector whose modulus value is always 1. The vector is a unit whose modulus or magnitude value is 1. So modulus A vector, modulus B vector value should be 1. And theta is the angle between them. The angle between the vectors A vector and B vector is given theta. Then show that there will be 3 subdivisions. The first one, sin theta by 2. Important is see these 2 only for theta. Okay, theta by 2. Angle by 2. Half of modulus A vector minus B vector. Second one, cos theta by 2 is equal to half of modulus A vector plus B vector. And third one, tan theta by 2 is equal to modulus A vector minus B vector divided by modulus A vector plus B vector. You see, suppose all the 3 subdivisions are given, the third subdivision is very easy. According to first and second subdivisions, you have any idea? The third one is very easy. Suppose all the 3 subdivisions are given. You see 1 and 2 proof. What is the value of sin theta by 2? Half of modulus A vector minus B vector. Cos theta by 2 is half of modulus A vector plus B vector. The third one is tan. You know very well tan theta is nothing but sin theta by cos theta. So we divide first one by second one. I exactly divide it. Sin theta by 2 by cos theta by 2 is nothing but tan theta by 2. In division half of will be cancelled. Then directly will come modulus A vector minus B vector divided by modulus A vector plus B vector. It's very easy one. Third one. Now first we prove the first one and the second one. Okay, in solution given A vector and B vector are the unit vectors. First we using this data. A vector and B vector are the unit vectors. Therefore whose modulus value should be 1. Therefore modulus A vector and modulus B vector should be is equal to 1. First we prove, to prove first one, sin theta by 2 it should be is equal to half of modulus A vector minus B vector. Usually in a proof, I will take LHS and we get RHS. Or we get RHS and will come in LHS. But you see there is no relation between LHS and RHS. LHS is involving only the angle and RHS involving the vectors. So using these data to prove. So in a proof, one term is considered A vector and B vector. We already know the result. Modulus A and modulus B value should be 1. So I will be take now modulus A vector minus B vector the whole square. I will take that value. So how to come sir modulus A vector minus B vector the whole square? In the proof, modulus A vector minus B vector is involved. Now I check whose square value. So modulus A vector minus B vector the whole square. So explain any manner. I write it is for convenient A vector minus B vector the whole square. Modulus square is there, so I write any manner. What is the formula of A vector minus B vector the whole square? It is not A minus B the whole square. It is A vector minus B vector the whole square. Formula is A vector square minus 2 A vector dot B vector plus B vector square. Or we write A vector square plus B vector square minus 2 A vector dot B vector also. First I write the positive value. A vector square is also we write modulus A vector square. And B vector square, how to write? Modulus B vector square. Modulus B vector square minus 2 A vector dot B vector. What is the value of modulus A vector? The value of modulus A vector and modulus B vector, it should come 1. So 1 square minus 2 A vector dot B vector. You remember the formula of A vector dot B vector? A vector dot B vector formula is modulus A vector modulus B vector cos theta. The value of 1 square 1. Again the value of 1 square 1 minus 2. The formula of A vector dot B vector is modulus A vector modulus B vector. Already given the angle between A vector and B vector is a theta. So cos theta. So the value of modulus A vector minus B vector the whole square. A vector minus B vector the whole square. Now 1 plus 1 is 2. Minus 2 of, again, modulus A modulus B value is 1. So that value becomes modulus A vector minus B vector the whole square is equal to 1 plus 1 is 2. Minus 2 of all values is 1, 1. 1 into cos theta. 2 minus 2 ones are 2. Again 2 ones are 2. 2 cos theta. You see in these two terms the number 2 is common. So we will take outside 2. 1 minus cos theta. So modulus A vector minus B vector the whole square is equal to 2 of, you remember the formula in trigonometry? In trigonometry the formula of 1 minus cos 2 theta. We already see 1 minus cos 2 theta. But here 1 minus cos theta. So the formula is 2 sin square theta by 2. Suppose 1 minus cos 2 theta is there, the formula is 2 sin square theta of. So here theta only is there, the half of theta is theta by 2. It is the formula of 1 minus cos theta is 2 sin square theta by 2. I write the formula. Since 1 minus cos theta is equal to 2 sin square theta. Suppose the plus sign is there. 1 plus cos theta. 2 cos square theta by 2. In next second subdivision we use 1 plus cos theta. So 2 sin square theta by 2. Okay. The next step. 2 2s are 4. Or I write it is 2 square. 2 2s are 4. Or we write it is 2 square. Sin square theta by 2. What is LHS? Modulus A vector minus B vector the whole square. What is our proof? To prove, you see the proof. Sin theta by 2 is equal to half of modulus A vector minus B vector. So you have any idea? We come close to the answer. We do one work. You see all are involving square. Okay. So the next step, taking positive square root on both sides. For convenience, I write one more term. I write 2 square sin square theta by 2 as 2 sin theta by 2 the whole square also. Okay. We write 2 square sin square theta by 2 as 2 sin theta by 2 the whole square. The LHS is same. Modulus A vector minus B vector the whole square. The next step, taking positive square root on both sides. So the square will be removed. So modulus A vector minus B vector is equal to 2 sin theta by 2. Okay, taking positive square root on both sides. You don't write in words. Just using the symbol which implies we remove the square symbol. So taking positive square root on both sides, we get modulus A vector minus B vector is equal to 2 sin theta by 2. Just only one work. The multiplication 2 becomes that side division. So 1 by 2 modulus A vector minus B vector is equal to 2 sin theta by 2. The multiplication 2 becomes that side division. So 1 by 2 modulus A vector minus B vector is equal to sin theta by 2. That is, we write it is sin theta by 2 is equal to half of modulus A vector minus B vector. So it is a proof of the first one. So we prove the first one. So first one proof is over. We are using this result, so I put it is equation. In third one, we use this result, so I put it is the first equation. Now we prove the second one. Okay, now to prove the value of cos theta by 2 is equal to half of modulus A vector plus B vector. First we write the proof. We prove in which term? To prove cos theta by 2 is equal to half of modulus A vector plus B vector. Using the same way of the first subdivision. In first subdivision, one term is involved. The term is modulus A vector minus B vector the whole square. Here modulus A vector plus B vector is there. So now when we take that value of A vector plus B vector, the term is involved. But we need some cos theta by 2 terms. So we check what is the value of that one. In previous one, we take modulus A vector minus B vector the whole square because modulus A minus B vector is involved. Here, modulus A vector plus B vector is involved. So we take modulus A vector plus B vector the whole square. How to write that term? A vector plus B vector the whole square. You know A plus B the whole square formula. A square plus B square plus 2AB. So what is the formula of A vector plus B vector the whole square? A vector square plus B vector square plus 2 A vector dot B vector. Here also we are using the same. So modulus A vector plus B vector the whole square is equal to A vector square plus B vector square plus 2 A vector dot B vector. We write A vector square is also modulus A vector square, B vector square as modulus B vector square plus 2. The formula of A vector dot B vector. The formula of A vector dot B vector is modulus A vector modulus B vector. Given angle between A vector and B vector is a theta, so we use theta. The next step, using the values of modulus A and modulus B. The value of modulus A vector and modulus B vector, both the unit vector, therefore whose values are 1. 1 square plus 2 of 1 into cos theta. So 1 square 1, again 1 square 1 plus 2 ones are 1, 2, again 1. So final answer is 2 cos theta. 1 plus 1 is 2. You don't multiply 4. 1 plus 1 2. This 2 is multiplied with cos theta. So 1 plus 1 is 2 plus 2 cos theta. In this 2 term, which one is common? The number 2 is a common, so we take outside. 1 plus cos theta. I already tell the formula. If 1 minus cos theta is the first one, the formula is 2 sin square theta by 2. Suppose 1 plus cos theta is there, the formula is 2 cos square theta by 2. I write the formula. In trigonometry, the formula of 1 plus cos theta is 2 cos square theta by 2. If it is a minus, instead of cos here, sin. If it is 1 plus cos theta, the formula is 2 cos square theta by 2. LHS is same. Modulus A vector plus B vector the whole square. RHS outside already 2 is there. The formula of 1 plus cos theta is 2 cos square theta by 2. The next step, using the previous one, is same. Modulus A vector plus B vector the whole square is equal to 2 2s are 4. We write 4 also 2 square cos square theta by 2. Suppose we write the square is common. How to write? We write it is 2 cos theta by 2 the whole square also. I am using this step as 2 cos theta by 2 the whole square. You see 2 square value is 4. Cos theta by 2 the whole square is a cos square theta by 2. What is the reason to write in this manner? In LHS also 1 square, RHS is also a square. So taking a positive square root, the square sign will be removed. So modulus A vector plus B vector value is 2 cos theta by 2. But in our proof, again we see the proof. What is the proof? We prove cos theta by 2 is equal to half of modulus A vector plus B vector. But this cos theta by 2 is a multiple with, you see, cos theta by 2 is multiple with 2. So the multiplication 2 becomes that side division. So half of modulus A vector plus B vector is equal to cos theta by 2, that is cos theta by 2 is equal to half of modulus A vector plus B vector. We prove the second one also. Okay, it is the second one. So I put it is a second equation. Now to prove the third one also. So in third proof, we divide just 1 by 2. 1 by 2 means the first equation divided by the second equation. You see the first equation. The first equation is sin theta by 2 is equal to half of modulus A vector minus B vector. And the second equation is cos of theta by 2 is equal to half of modulus A vector plus B vector. The third one is to prove tan theta by 2 is equal to modulus A vector minus B vector divided by modulus A vector plus B vector. So I divide the first equation by the second equation. So 1 divided by 2. The first equation LHS is, we see the first equation LHS is sin theta by 2 by. The second equation LHS is cos theta by 2 is equal to. Now come in RHS. The first equation RHS is 1 by 2 of modulus A vector minus B vector by. The second equation RHS is 1 by 2 of modulus A vector plus B vector. I already tell this 1 by 2 is cancelled. Sin theta by cos theta is tan theta. So sin theta by 2 by cos theta by 2 we write it is tan theta by 2. Sin by cos is tan theta by 2 is equal to modulus A vector minus B vector divided by modulus A vector plus B vector. It is a third one. Suppose in 2 more questions, Or one more question, just what is the value of that one? You just memorize this result. You don't memorize the sum, you memorize this result. The value of sin theta by 2 is half of modulus A vector minus B vector. The value of cos theta by 2 is equal to half of modulus A vector plus B vector. So, suppose all the three subdivisions are given, so we directly write 1 by 2. Suppose this result only adds. So what is the way? We know that. We write the first result, second result. And we put these equations by 1 and 2. Divide 1 by 2, we get the result.